A fistful of pickles, or programming shouldn't take very long. When programming takes too long, it means that there aren't enough good tools. Programming is a desperate science, and it is often true that programming bare bones is probably best. But complexity is always increasing, and what is bare today will shift tomorrow. There's a lovely and rebellious movement called behavior-driven development, where people speak basically a subset of English called Gherkin, as in a pickled cucumber, and describe what they need and how the programs should operate and what they should return. And they throw in a little test just to see if the program meets the standards that they described. And then real programmers come in and convert that very text, really bind that text to code, so that if that text ever changes, if someone rewords something, new code will have to be put in there. The old code will not work with changed text. Well, it just so happens that for some reason 2023 became the year of artificial intelligence. We don't, quite have it, but we could be close, maybe. Though, thanks to the language models that we do have, we can get a good idea of what it will be like when it finally gets here. Now, what we do have and what is reliable is good enough for dealing with subsets of English and the creation of small programs that are well described and well tested, which is what behavior-driven development does really well. That means the large language models can attempt to create the code that the BDD describes, and that it may be possible to create programs by simply writing all the stuff in Gherkin. Now, there is a problem here, because even with artificial intelligence or language models, what do you say, and where do you even start? There's a solution to that. You start with visual programming and packet-based programming, where you send packets through filters or actions that transform them or fork them into multiple wires, where they can be transformed in different ways. Visual programming languages demand high-level actions and filters, though. You can't just do everything with map, reduce, and filter. You need some really good stuff that the end user can understand what they really want. So, instead of talking about querying a database, what people really want is to drop a box that represents all the users, for example. And when connected to something else, all the users will stream through it, so that the creator of the visual program can filter things and send them different ways. Accounts receivable, bounced credit cards, complaints, and the like. Until now, the best we had was actually pretty good. It was making high abstraction visual programming nodes, like the user node that streams out all the users in a system, with low level visual programming that would call for writing some functions, so a programmer needed to be in the loop. This, again, is very good. It's luxurious even. But it takes time, planning, implementation, and it requires that gosh darn programmer. Ew. But by introducing BDD to visual programming, we can describe a visual programming action in English, and then, this being the future of 2023, how amazing, we can then send it to an AI and see if the solution that the AI comes up with, which is sometimes wrong, but still see if it passes the tests. The tests are always easy to make, so the AI can take care of them somewhat reliably. The implementation of the feature itself will need to pass that test. Here, we can focus on describing actions in English and without any programming or the need for a programmer. It is still not perfect, but the result is the entire internal communication network that is normally completely obscured inside programs, not only visually mapped out, but also editable. Just boxes and wires connected together. More than that, it means that the really tough guts of the program get done long before the user interface comes into question, which is usually tedious and comes with many little adjustments, not changes, not development, but shifting things around to get it quite right for all the users. Redux is an example of how it is a big win to get the internals of a program all done and then worry about all the user interface fluff. User interfaces are traditionally built using nested boxes, as in button is in a footer, footer in a form, the form is in the main area is in the body, and the body is in the viewport which sits in a window. Now, this happens to be really cool because when you nest things, you don't have to talk about X and Y coordinates, but instead you talk in terms of padding and margins, as in when nesting a button in a form, in order to position it correctly in the right place, you just adjust the margin, maybe alignment for that container that's nested inside something else. The chat user interface or conversational user interface shows that there are other things out there that can really deal with complex form logic. Here, forms can be filled out by a bot interrogating the user, and the user interface itself is basically text, maybe with some controls such as color picker or a date picker, but it's largely text and there is no need for nesting. Very cool. There's more to discover in this area. Talking to multiple bots over email or something similar to email is another kind of conversational UI where the power of text is greatly multiplied with bots talking to the user and, yes, each other. Some programs also don't need user interfaces. Rewriting web pages is about tiny programs that are internal to user script managers, internal to web plugins. So the visual programming pipelines are all it takes to get programs done. There is no user interface. The web page just changes as needed. Database browsing programs are another thing. Here, you just need a cursor to bookmark your position in the list of rows that you pulled up. Then you need a search box where you can search for new records, and some kind of a form builder that works on top of a grid, just kind of drag and drop columns together. Visual programming language with nodes that represents departments or department managers, department heads, can go a long way to automate an entire company. Here, some nodes would represent an actual person even. They would be part of the visual program workflow, a very slow action that instead of a CPU, uses actual humans. So there would be a queue that would go down over the course of the work week. You see something very similar, well, kind of, in the self-checkout machines at your local supermarket. Those computers aren't actually smart enough to serve everyone. They sometimes call out to the person that's monitoring all the systems so that they can come in and maybe adjust something or cancel something or take something out of the bag and magically put it back in to make things work. So the computer actually employs a human as a creature that has nimble hands and is a lot smarter than it. Yeah. And finally, the visual programming language, or canvas, is a user interface in itself. The end user simply demands high-level actions, and if you get them in there, and if they are relevant to the user, it's a user interface as powerful as you could possibly hope for. Here, the user can create all kinds of automation flows, connecting temperature or weather predictions to furnace control, for example. Instead of hoping to find an app, they can just kind of splice a network of nodes as needed. If visual programming was more popular, and I don't know why it isn't, since it's so approachable and simple to operate, and nodes were made with BDD and AI, or even code bounties. For example, $50 to finish my node, and the user could then wait for a week and have multiple users offer their solutions, where the user picks one and the person gets paid. Again, you can see here how the human is put in the loop of developing nodes. Creating programs for home or business, or programs that make a business, would be possible even for non-programmers. So as long as they have those nodes that they can connect and reason about and build on top of. Yeah. It used to be that clicking view source on a web page would reveal the bare bones. But times have changed. Today, we should be able to view the internal communication network of all kinds of applications, to learn from it, to get inspired by it, to reason about how software works. It would all be represented by a beautiful visual programming language that in some brilliant and daring instances could actually allow for adding new features or adding new feature requests. Using AI to generate program code truly does accelerate development. It just lacks that structure of where to put it. And visual programming languages are that structure, those informative boxes and the wires that you can follow from box to box explain everything. Generative artificial intelligence that can generate code combined with visual programming languages is a new revolution waiting to happen, a gateway to a more programmable world.